we have learned is only array and how your application of array and that is one of the application of array, multidimensional arrays, past matrix we have seen. So now we are going to enter into linked list. As I told you before itself, array, when you want to insert an element in an array, or if you want to delete an element in an array, what happens is normally you want to shift up or down. If you want to insert, I have to move all the elements up, or if you want to insert in the middle of an array, I have to shift the elements down and insert it in the middle. So that takes extra time. Similarly, when I want to delete an element in the array also, the space will be freed out, right? So again, all the elements I have to move to the front. This what happens normally in an array. So what we are doing is to use our memory space efficiently, and also to make our operations easier, we are going to use linked list. So linked list, what it will do is, initially itself it won't create any memory space. It will dynamically create whenever needed alone. That is the main advantage of your linked list concept. When you need to insert an element, a memory will be created. If you want to delete, then that element will be deleted, and that memory also will be free out. So this is what, or it will be deallocated, I can tell you, in any word you can call. So this is what happens in linked list. So how we are going to process this linked list, we will see it one by one. So here normally a linked list ADT means it is a series of connected nodes where each node will be a data structure. It is called as a data structure because data structure, as I already told you, there are many operations we can perform. For a particular node itself, I can perform multiple operations in it. Either I can ask to retrieve the element, or I can ask to give out the address of the particular next element, or I can search an element, or I can insert an element, delete an element, everything. So based upon the linked list or number of elements you are creating in a linked list, based on that only your memory also will be allotted, or a list will be created. In case your list can expand as well as it can shrink also. Expand in the sense, if you want to add more elements, your list can keep on expanding. Shrink in the sense, if you want to delete an element, your linked list will become small. If you are deleting multiple elements, I have 5 elements in a linked list. That means your size will be 5. Your length is 5. Or else now if I have only one element, no, I am deleting 3 elements. Now immediately my linked list size will become 3. So it is getting shrinking and expanding as your program runs. Okay, so insertion and deletion of nodes will be quicker. So, and now see here, dynamically allocating elements. Allocate elements one at a time as needed. Okay, only one will be allocated at a time. And maybe if there is any other element to be added up, it will give the address of the next element. Or else what it will do is, immediately it will be null because there are no more elements at the behind. So now see, array of elements. These are the elements in an array. For example, there are 3 elements, something like Jane, Bob, and Anne. Now I want a linked list. So how? Jane will have the address of Bob when I'm creating. So that what will happen is, when I'm accessing, when the pointer is in Jane, it will help you to move to the Bob also. Now Bob will have the address of the third element Annie. So what will happen? It will again have a link over here. So this is singly linked list. So you cannot, only one disadvantage here is you cannot traverse backwards. Only thing is, if you are moving forward, you can move only forward till the end, till you reach the null. Backwards is not possible in your singly linked list. But in doubly linked list, it is possible. So this is what your dynamically allocation. And when you want to include a particular element, dynamically only one memory space will be created at that time. So here you see a series of elements that are not necessarily user linked list. So these all are the pointer implementation. See here A1, this is your structure, A1, A2, A3, A4, A5. And this is your diagrammatic representation. So this is having the holding the address of A2, it's holding the address of this. And A1's address will be in the default node called as head node, which is a dummy. It will hold some dummy value where the first pointer will always point to this node. Okay, that I'll teach you again. It comes again. So A4, A5, and finally there is no more element apart from A5. So I'll mark it as null. That's all. So each node contains an element and a pointer. So element is this, or a value I can tell you, and a pointer to the next node. Or else you can call it a successor also, containing its successor's link. Okay, and the last link will be always null. And these all I told you earlier. Compared to the array implementation, pointer, much space is not needed. That is what represented here. Now, when I go here, I can say same thing only in detail. The slideshow, it is in detail. A head node, always there will be a head node. It's a default value here, which is assigned based upon the system. And now see here, A, B, C. This is null. Either you can give NULL or you can give this representation also. So it will be a series of connected nodes, and it will have a piece of data. That means a data and the pointer. Pointer will be always pointing to the last node will point to the null position, but the previous pointers, everything will have its own next one's address. So basically this diagram you have to keep in mind: a node and a data and a pointer. This is a series of nodes where the last node you have to always keep it as null. Now see here, no estimate of the maximum size, we do not know, no wasted space, and normally your searching time or insertion, deletion, everything will be only your time is, I told you, time consumption is very less. So it will be normally O of 1 only. When you want to find any element alone, it will traverse. So it will be based upon the n element which you are going to search. Based upon that, it will move. So that searching will be, and printing also, because printing also we need to print from the first element to the last element. So anyway, n elements needed. For finding an element also, you need to search until that particular n element. So that is what is. But finding the kth position also based upon the particular element. Insert and delete, normally dynamic allocation, right? So only O of 1. I'm just inserting as a new, I'm going to delete as a particular element. So now see, this I have already told you about this singly linked list, not just now. And now doubly linked list will be, see here, in singly linked list only.
Ma'am?
Yeah.
Ma'am, how that search and delete, the insertion and delete is O1 in O1 time?
O1 time is, see here, insert at position 0. That is making a new element. Okay. That's what. So now see here.
Ma'am, won't we have to first search the element to delete it?
Which one?
Ma'am, when we have to delete a node, won't we have to search that node first?
That is only searching only, it is taking time. No? For searching it is O of k. But for deleting, requires no shifting of elements. Deleting will happen only after the particular element.
Only possible at position 0, right?
No. See, insertion and deletion, why we are telling it as O of 1 is, when you want to insert an element, we are going to, maybe at the position, if you are going to, see, if you are going to insert at the first position, there is no searching at all. Insertion will have multiple criteria over here. Maybe you will insert at the first position, at the last position, at the middle, any location also. 3 types of insertions are there. So when you want to insert at the first position, there is no way of searching. So it is just you will insert at the 0th position. Okay, so it is O of 1 only. Similarly, when you are going to insert at the last position also, insertion algorithm will work only after finding the last position. Understood now? Only. So at that, till that, only the searching algorithm is taking into count. Only your finding will be taking time, and after that only you are going to call the insertion procedure itself.
If the element is in, we want to insert an element in middle or somewhere in the middle, then it will first find the element. Then
first find the location. Location it will find.
And then ma'am, it will change the pointers to point to different locations. Then how it will be O1?
see, the insertion algorithm will be only, that is only one, making a new element in this position. Insertion, that is here in the middle element alone, your case will differ. When you are inserting, as you told, your pointer will differ, right? So you need to change the pointer. So that alone will differ. But in the other cases, mostly it will be O of 1 only. Because searching only, your searching algorithm only will keep on searching each time. And even for deletion also, only after finding that element. But see here, it is given here, insertion and deletion becomes easier, but finding the kth element moves from O of 1 to O of n. So when it finds a particular element, or when it finds the location, just insertion happens. So dynamically only at that time only your the memory space will be created and your element gets inserted. And when you want to delete also, you will be finding it and you will delete it. Okay, so normally your general thing will be mostly insertion and deletion will be the O of 1 only. Understood? Okay. So when I explain the code, you will be more clear in it. Okay. So next is doubly linked list. This is just first introduction part only. Doubly linked list, as I told you, you will be having a forward pointer and a backward pointer. You can tell it as first point, forward and backward, or a reverse pointer is also possible. You can tell it by various names. So this will have, A will hold the address of the next pointer, and B will, that is A holds, since it's the first node, initially there will be a dummy variable, dummy address will be there, where A's address will be stored here. And now A will hold the address of the B's. B will hold the address of the A as well as C. And C will hold the address of B, and if it is the last node, no other way, it is null. So what is the advantage behind this doubly linked list is you can traverse backwards. You have a for front and back pointer, you can tell, or you can tell it as a forward and backward, or forward and reverse, whatever name is applicable you can use. But the thing is, it has two pointers which holds the previous node's address and the next node's address. That is your doubly linked list. In circular link, but in the disadvantage in doubly linked list is you can move from front to back. If I want to retrieve back, I'll go here. If I want to come in front, I'll come here, I'll go there. Everything is possible. But from C, I cannot go back to anywhere because it is an end. So when I take this circular linked list, it is possible. In circular also, both are possible. Singly linked list circular also is there. Doubly linked list circular also is there. But in your thing, both are possible, but we are going to learn only about the circular linked list of your singly linked list alone. But same thing only is applicable for W also. So see here, same, only one advantage, that is when I come to the last node, and our last node C node will not be null. Instead, it will go to the first node of, that is, I can take the address. This will hold the address of A's node, or this will hold the address of your first node. That is only called as your circularly linked list. Now this is the main thing, how to create. Now we are going to enter into the singly linked list concept. Till now I told what are all the singly linked lists possible. Singly linked list, doubly linked list, circular linked list. This only we are going to study now. So now how the singly linked list is, we are going to create the structure of the particular node. So these lines are very, very important in all the code. Your node will be of structure type because you have two different data types over here, an integer value and a struct node. This itself is a node. So that this is a data type, or DS concept I can say, DS type. So struct node, this next will be holding the address of the next one's, this will point, or this will hold the address of the next value. And you have to, this line is also very, very important. Your head node, your default giving it as null. Your head node should be null. So how you are dynamically creating is using malloc. So dynamically creation procedure, as I told you, it will be malloc. Malloc and free. Malloc you will be using for C, malloc, and free you will be using for your deleting, deallocation procedure. But you can use this in C also, C++ also. Can anyone tell what you're going to use in C++ for allocation of memory?
New.
New, yes, new. And what should be the deallocation?
Delete.
Delete, yeah. Yes, delete. Good. So these are the things which you have to keep in mind. In C, malloc and free, and in C++, it will be new and delete. So you can use any C or C++ according to your convenience. So now see here, the head pointer points to the first node. If the head is null, see, first initial thing is whenever you are going to insert a node or you are going to create a node, the first initial procedure checking condition is you have to find whether the particular, whether the list is available or not, or I can tell you whether it is empty or not, or it is already having some values in it. Okay, that is the main thing which you are going to do. This is not only for linked list, this is for all. Even for stack you have to check, for queue you have to check, and for tree, everywhere you will be checking this condition. This condition in other way I can tell you underflow and overflow, but that comes differently in stack and queue only it comes. But here what you are going to check is whether the linked list is empty or not. So initially head is null and you are allocating this node. So this is a diagrammatic representation. Now I'll tell you how to create a node. So how to create a node to a linked list? That means to add a node, whatever it is. So first you are going to begin node creation. Create a new node. Store the particular data in the new node. If there are no nodes in the list, that is that the node which you are going to create is the first node, always you have to make that node as the first node. Otherwise what will happen, the next one, now already A is there, na? You are creating B will be added after A, and now C, if you want to, if you are adding, C will be added after B. But there are nothing in the list, you are creating a node C or A or B, whatever, that will be the first node. So if there are no nodes in the list, make that new node as the first node. Else traverse, you have to use a pointer to move from the first node till the last node, and you can add the new node after the node which is available there. So that is what your normal procedure. So you have to keep two conditions in mind. One is you have to check whether the list is empty or not, whether the node which you are going to add is the first node or already there are some elements in the node. If there are already some elements in the node, traverse and add it later at the last. So default situation is always the node gets added up. If there are already nodes in the list, your whatever node which you create will be added up towards the end of the list only. That is your default condition. But unless if you specify that I need to add it in the front or I need to add it in the location where I give, that means it will ask you some conditions. But your default condition is always it will add to the end of the list only. Normally, when you want to go and add something even in an array, we are getting 5 elements in an array, you will be getting 1, 2. Now when you give 3, it will come after 2 only. It won't go in the first instance. Similarly, when I give 4, it will come after 3 only. Likewise, in linked list also. So here operations is, you have to check whether it is empty. You can insert a node, you can find a node, you can delete a node, you can display the list. These all we are going to see it one